Okay, so in this video, I wanted to show about Fibion Krono and the reports it is creating. So just quickly, it has light sensors, it has 3-axis accelerometer, it has a temperature sensor. So it's measuring very important data for sleep and circadian rhythm. And I just quickly show that it also has the temperature sensor here with the good large skin contact area. And for the sleep detection, it uses tap method, which is validated against PSG. And it's more accurate than only activity-based estimation. So it takes into account temperature, activity, and wrist position. And if we look then the report, so this is from the free software, these are automatically created from the measurements. So here are first mean value of indexes. So you get the total time of sleep. This person has been sleeping a lot. Mean intensity of light, so in lux, and mean intensity of activity. And you always have the green or the red can be in different ends depending which way this, and for example, mean temperature should be in the center. So you can see the green, red. And then there is sleep depth, light during sleep. So how dark is the room? For example, here it's 0. So the room has been totally dark during the night. Then there is amount of activity during sleep. So basically wrist movement. There is temperature during sleep. And then there is values during wakefulness. So basically you have gone to sleep, but you have some waking period. And then there is also a little bit of the time of day when the person is central hour of sleep, central hour of darkness, and so on. And then there can be different chronotype. This person is undefined chronotype, basically. And then it provides mean circadian rhythms. So you can see here the curve, and the dashed line shows the average profile of a person, normal sleep, and then you have the pink color for this person. And you have different parameters again of this. You have regularity, fragmentation. You have for sleep, the dashed line shows the average profile of a person with normal sleep. And here we can see this person actually sleeping more, over 10 hours in this measurement, 11 hours almost, and good parameters in overall. And then there is the visible light and circadian light. So you get the different parameters for the light during different times of day. So for example, here we can see that from midnight to 8 in the morning, very little light at all. And then we can see the amount of blue light and overall visible light. And of course, in the evening, it'd be good that both would start to go down after 8, and especially the blue light would be good to go down. And then we have skin temperature. So what is the mean temperature? Temperature in wakefulness, temperatures in sleep, and so on. So you can see here, the dashed line is here. This person has a little bit bigger fluctuation. And of course, we measure it from the wrist. So it's not a core temperature, but the measurement values are a bit lower in extremities. And then you see physical activity, intensity. You see the normal person here. So this person is doing a bit less activity with less intensity than average person, and you get different variables for this one. And then you get daily recording of temperature activity. So these are just visualized here that you can look them more closely. And then we have this kind of that can be used for participant feedback. So do you usually sleep in total darkness? So this is based on the measurement. So this person was sleeping in a very dark room. Do you regularly expose yourself to more than 7 hours of darkness per night? Yes. Do you normally expose yourself to more than 2 hours of natural light outdoors? It was not picked that there was enough outdoor light for this person. And does your sleep time fit between 10 p.m. and 10 a.m.? And this person went to sleep around midnight. So it was later and he woke up after 10 a.m. So didn't get that one. And the person was more sedentary, didn't have rest for 2 hours before going to bed, did not walk, run, or cycle 30 minutes during this day. So we can see that the intensities of activity were much lower there. And yeah, this one is actually a test report. We have been still translating this another language. So this one is not yet ready. This part we will change it. And then about sleep, do you sleep between 7 and 9 hours per day? So this person was actually sleeping over 10. Maybe there was a little bit of sleep deprivation. Are your naps shorter than 30 minutes? Yeah, I think there was a longer nap than 30 minutes. And with this question is that if you sleep for too long in the daytime, it can kind of wash out your certain molecules from the brain, and it is more difficult to fall asleep if you sleep too long during the daytime. I especially have this. If I have a nap, I need to keep it really short. I need to put an alarm that I can actually then fall asleep again in the evening when I go to sleep. Do you wake up at the same time approximately every day? So of course for this we need several day measurement that we can get this. And does your sleep occur between 10 p.m. and 10 a.m.? And this was already in the other part. And then you get a little bit of numbers, how much each variable is, and also mean wavelengths and circadian indexes for research purposes. And you can get these also as a CSV export. But many kind of values, these come automatically, and it's very easy for participants. You just wear the device, the battery lasts 21 days, and the memory can record 42 days. So you can go over 1 month measurement just by charging once. So you connect the USB and a USB connector and charge it once during this period, and you can go well over 1 month. And it has a marker button, so you can ask participants to provide certain markers. For example, when they go to bed, could be one of the markers to get. And maybe a few words about the temperature sensor. So it's very high precision, and because it has a really good skin contact, it actually protrudes from the device. We are actually measuring the skin contact. Some devices have the temperature sensor inside the device. And yeah, there's not too many use cases when it's inside the device because we are kind of measuring, depending on the situation, partially the skin temperature and partially the outside temperature. And it has an accuracy of zero point 0.1 Celsius. And you can use dim light melatonin onset algorithms to actually calculate from the temperature change the DLMO, which is very useful. Otherwise, you would need to get melatonin samples, and this one is also scientifically validated. And we also use the temperature sensor for off detection. So when there is a clear temperature drop, we can conclude that the person removed the device from their hand, maybe going to take a shower. So thanks for watching. And if you want to get more info, you can book a video call, for example, with me from this link. You can connect with me on WhatsApp, or you can send us a message or ask a quote. Thanks for watching. Have a brilliant day.